Hi friends, welcome to a new video of Masters Academy, second PUC Physics, passing package questions for supplementary exam, part first, prepared by SANTHOSH Kumar PK. This video is prepared on request of some students as a passing package for second PUC supplementary exam. First chapter, electric charges and fields. One more questions. First question, write the SI unit of electric charge. Second question, define SI unit of charge. So don't get confused with these two questions. This is write the SI unit. You have to write the SI unit, and here you have to define the SI unit of electric charge. Third question, state Coulomb's law. Fourth question, what is an electric dipole? Fifth one, write the SI unit of electric field. Sixth question, how does the electrostatic force between two point charges change when a dielectric medium is introduced between them? Seventh question, mention one method of charging a body. Two more questions. State and explain Coulomb's law in electrostatics. Ninth question, write Coulomb's law in vector form and explain the terms. 10th one, write two properties of electric field lines. Sketch the electric lines of force. Electric lines of force is nothing but the electric field lines. Electric lines of force due to a point charge Q if Q is less than 0 and Q is greater than 0. It is nothing but Q less than 0 means a negative charge, Q greater than 0 means a positive charge. Next question. State and explain Gauss law in electrostatics. Next, three more questions. Question number 13. Mention any three properties of electric charges. Mention the properties of electric field lines. If it is asked for 3 marks, you have to write minimum 3 properties. Here, in 2 more questions, you have to write minimum 2 properties. Next, 5 more questions. 15th one. Derive an expression for electric field due to electric dipole at a point on an equatorial line. Next question. State Gauss law in electrostatics. Derive the expression for electric field at a point due to a infinitely long charged straight conductor using Gauss law. Or this question can also be asked as derive the expression for electric field at a point due to an infinitely long thin charged straight wire using Gauss law. 17th question. Derive an expression for electric field due to an electric dipole at a point on the axial line of the dipole. Next, 18th one. Derive an expression for the electric field at a point due to an infinitely long thin charged straight wire using Gauss law. State Gauss law in electrostatics. Using the law, derive an expression for electric field due to a uniformly charged thin spherical shell at a point outside the shell, and this is maximum times asked in your previous paper. This question can also be asked as derive the expression for the intensity of electric field at a point outside the uniformly charged spherical shell using Gauss law. What happens to the expression when the point is on the surface of the shell? And these questions are from first chapter. Next, let us move on to second chapter, electrostatic potential and capacitance. One more questions. What is a capacitor? Next question. What is an equipotential surface? Next question. What is electrostatic shielding? Next, 2 more questions. Mention any 2 factors on which the capacitance of a parallel plate capacitor depends. Next, 3 more questions. Derive the expression for potential energy of a system of 2 charges in the absence of external electric field. Next question. Derive the expression for capacitance of parallel plate capacitor. Next, 8th question. Derive the relation between electric field and electric potential due to a point charge. Next, 9th question. Derive the expression for energy stored in a charged capacitor. 10th one. Obtain the expression for effective capacitance of 2 capacitors connected in series. Next, 11th question. Derive an expression for potential energy of electric dipole placed in an uniform electric field. Or derive an expression for the potential energy of a system of 2 point charges in an external electric field. 12th one, obtain an expression for effective capacitance of two capacitors connected in parallel. Next, 13th one, derive an expression for the energy stored in a capacitor. Next, 5 more questions. Define electric potential due to a point charge and arrive at the expression for the electric potential at a point due to a point charge. So disclaimer, the questions used in this video are taken from previous year annual exam papers. That is, these questions are taken from the previous year papers from 2014 up to 2020 March. Dear friends, if you like this video, please subscribe our channel and share it to your friends. Thank you.